Hey guys, welcome to week 5 of your college algebra class. Today we are going to take a look at solving applications involving simple interest. So we're looking in section 1.2. So it's still chapter 1, but 1.2. These chapters, as you can tell, are really long, but this is the last section that we are going to take a look at in our algebra class. In this section, like I said, we're looking at interest. So interest, you guys have seen probably in many places before. We use interest when we are purchasing a car. Oftentimes we have to take out a loan, and there is a certain interest rate, meaning that when the company gives us that loan, we don't just borrow, let's say, $30,000 and then just pay them back $30,000. There's interest that accrues over time so that they end up getting more of a profit from us, and those loan companies end up, that's how they survive. When we buy a house, there's an interest rate on our house, so same reason, we take out a loan. If I borrow, let's say, $200,000 to buy a house, again, the loan company is not going to just get back the $200,000. They're going to get back more. Same thing with our student loans. You guys are probably very familiar with our student loans. We took out a certain amount of money from different loan companies, and there was an interest rate on those loans. So what you guys are looking at in this section, so if you guys have your e-text, you guys may notice on page 95 it gives us an interest rate formula. This interest rate formula says that interest, so I'm just going to write out what it says here. Interest equals PRT, which stands for principal times rate times time. Now let me explain that a little bit further. Let's say we're talking about a student loan here. So principal is the total amount that we've borrowed for the student loan. The rate is the interest rate that loan company uses, again, so that they can, make a profit off of this. And instead of just lending you money, they have to, in order for them to be a business, they have to make a little bit of money off of you. So there's a certain rate that they charge in order to lend you that money. And then time is the amount of time that it takes. So the longer it takes you to pay off your student loan or your mortgage loan or your car loan, whatever it is, the longer it takes, typically the more interest is going to accrue, and they end up making more money from you. So the idea is to pay things off as quick as possible so that they don't make that much money. So this right here could be pretty easy if we just want to calculate how much interest has accrued over the amount of time that it's taken me to pay this loan back. So for instance, let's say I want to calculate the total amount of interest if I borrowed, let's say, and the example that they use in the book is $5,000. Let's say we borrowed $5,000. So, and let me actually write this over here in green. So our total amount that we have that we have borrowed is $5,000. Let's say the rate that company charges is a 4% interest rate, meaning that they're going to gain back 4% of what we've borrowed. And that's dependent on the amount of time. So let's say we pay this off after a year and a half. So put it in parentheses. I'm not really sure why. Because I'm following the formula here. So let's say 1 year and 6 months. Run out of room there. 1 year and 6 months. So what's going to happen in this calculation, so I'll write this down here in the formula, the blue. What happens is if I borrow $5,000, that's the amount of the principal. So what we're looking at right here. We multiply that by the rate, but instead of putting just a percentage in terms of calculations, percentages, we want to write those as decimals. So if you guys are familiar with how 4% would be written as a decimal, what we do is we take the decimal point at the end of that whole number 4 and we move it 2 places to the left, and that would make it 0.04. So I just wrote 0.04. Every single time you want to write a percentage as a decimal, we would just move that decimal 2 places to the left, because technically what you're doing is you're dividing that by 100, and that's how you turn that decimal into a percent, because the percents are always out of 100, and that's how we do that. So it's kind of like 4 out of 100. So if maybe that's an easier way to think about it, that 4% is the same thing as 4 over 100, and 4 divided by 100 is 0.04. So that's a way to think about that. But then we're going to multiply that by the amount of time. So there's our interest rate. And then we multiply that by the amount of time that took to pay off. And that was 1.5 years, so we use 1.5. We need that time to be in terms of years. Obviously, 1 year and 6 months is 1.5 years. So we would use the decimal there for that one. And so what happens when we multiply all these three numbers together? 5,000 times 0.04 times 0.15 is $300. So that's how much that loan company made from us. Not only do we have to pay back the $5,000 that they lent to us, but they also made an extra $300 because of the amount of time that it took and that interest rate. So in any case, let's say if I borrowed the same amount, even if and again, let me just put that formula up here. Interest is equal to principal times rate times time. Let's say that we wanted to calculate the amount of interest when we borrowed, let's say, the same amount of money, $5,000, but we borrowed it from a company that uses a 6.5% interest rate. So remember, 6.5 written as a decimal, sorry, my hands are not working today, would be 0.065 because we moved that decimal 2 places to the left. And let's say it took us 2 years to pay it off. So there's our calculation for this particular interest rate. Sorry, I'm grabbing my calculator here, making a bunch of noise. So we would take that $5,000, multiply that by 0.065, multiplying that then by 2. This company then made $650 from us, not just because of their higher interest rate, but also because it took us longer to pay that off. So they made a little bit more from us. So that's how interest is calculated. So in these problems, those are pretty straightforward. So you may see a couple of those on your all's midterm where we just have, I just want to calculate how much money that loan company has made from us if, that's what we borrowed and, over that, certain amount of time and that rate. But we're going to get a little bit deeper into these types of questions. What we're going to take a look at, and if you're still looking at your e-text, if you're not, that's okay. I'm going to write all this down for you. We are going to use linear and rational equations, to be able to describe if, let's say, the interest is what I knew. And even further, what if I borrowed from multiple loan companies? Sometimes when we take out student loans, sometimes I don't just borrow money from one company. Sometimes it's more efficient to borrow from 2 companies because maybe the original company had a pretty high interest rate and the other one doesn't have as high of an interest rate, and maybe the one with the low interest rate won't give us enough for school, so we have to borrow from 2. So what we're going to look at in these types of situations is what happens when I know how much I've borrowed, but I need to calculate how much was borrowed from each company. So let me give you an example. There's an example in your text that says this. And I'm looking at example 1. It says, and I'll write all this information down and I'll show you guys how this is calculated. So to give you an example, the example says that Kent borrowed $8,000. So let me write $8,000 here. Okay. He invested part of the money for 2 years, so 2 years, in a stock fund that earned I know I use the example so often as like when we borrow money, but this also can be calculated when we invest money. Sometimes when we invest money, so in some type of investment account, 401k, something like that, when we take our money and we put it into an investment, sometimes there's an interest rate, so meaning we gain more money based on the rate and how long that money was in that particular account. And that's what's happening here with Kent. He is taking $8,000 of his money and he's putting into 2 different investment accounts. So the first investment account, so he invested in for 2 years in a stock fund that earned 6.5% interest. That's pretty good. He put in the remaining amount of money into an 18 months, into a certificate of deposit, which we sometimes commonly refer to as a CD, that earned 2.5% interest. So what we do know, if the total amount of interest from both of these investments, Kent gained $855. So here's what we know. We want to know how much was invested into each particular account. So here's what we're going to do. I'm going back to previous slides. Remember, here's the original question. Kent had invested $8,000. The first was in a stock fund, so I'll put S for stock. That was over 2 years at a 6.5% interest. The second one was a CD that was invested over 18 months at a 2.5% interest rate. This was the total amount of interest. So what we had to do, and up a new page here and show you guys how we can use a chart to break this question down a little bit further. So remember, if we think about this, so the amount of principal, sorry, I'm just going to abbreviate this as PRIN, so we know that that means principal, is the total amount of money that we have invested. And we know that then there was a certain amount of interest that Kent gained from this. What I'm going to do is I'm going to put this in a little chart here, into a little table. So remember, the two funds that he invested into, one was a stock fund and the other was a CD. And then, so what we're going to see then is the total as well. And so this is how you'll kind of put together, this is how you're going to put together all of these types of questions in these simple interest formulas, because that's what we're going to see, is we're going to see two different accounts like you're seeing in this case. And we're going to know how much total interest was gained. So again, let's think about this. So Kent, we know he invested a total principal of $8,000. So again, that's the principal. We know his total his total interest that he gained was, I'm losing my pens here, was $855. So we know the totals already. What I don't know is the total amount that was invested into each account. That's what we're trying to figure out. It's not like he invested $4,000 into the stock fund and $4,000 into the CD. Based on these interest rates, he may have invested it a little bit differently. And what these companies may be allowed, some companies don't, allow only so much money to be invested into different accounts. So I need to figure this out. So what we're going to do is we're going to call that stock fund, we're going to call that X. We're just trying to figure this out, so that's our unknown. Then therefore, our CD is also an unknown, but that's going to be whatever's left over. So instead of just calling that a different variable, we're going to call that 8,000 minus X, because at the end, once we figure out what X is, once we figure this number out, we'll be able to figure out the CD as well by just taking the total, since we already know that, minus whatever that number is, because it's just the rest of the money that he had left over that was invested into the CD. Okay, so that we know. We know that whatever's happening here is, our linear equation, and there's going to be more to it. That's where this interest is going to come in down at the bottom. But we know that total stock plus the CD, so the 8,000 minus X, is equal to $8,000. We already know that, but there's more to it. If you remember, each company had a different interest rate. Each company also had Kent's money for only a certain amount of time. So there's more that's going to go into this linear equation. It's more than just this down here. Instead, we have to incorporate those numbers. So that's going to be written down here at the bottom. And this is where your linear equation is going to come in. So if you think about it, remember that our interest formula, let me write this down here at the bottom. Interest is equal to principal times rate times time. So our interest down here, each box is going to contain that interest formula. So if interest is calculated that way, then that means here in the stock fund, that means interest, that means the stock fund, which we're calling X. Remember, that's our principal. That's the total amount of principal in this particular column here. So X multiplied by the rate, if you remember the stock fund rate was 6.5%, I'm going to use that decimal, 0.065, invested over 2 years. So remember, that's the time. So it's principal times rate times time. So there's the principal, the rate, and then the time was 2 years. So that's going to be the first part of our formula. So our calculation is going to be more than just X plus 8,000 minus X. Instead, we're going to need to use this whole thing plus whatever we calculate right here in our CD. CD, very similar. That we need to put that interest rate formula in there. That we need to calculate that as principal times rate times time. So let me write that one in, let's see, I'll write that one in red. So our CD principal, remember, is 8,000 minus x. So I'll put that at the top. Times rate. The rate, again, for this CD was a 2.5% interest. So we need our, decimal version of that, 0.025. And it was invested over 18 months. If you remember, if we think about that the time needs to be, for the calculation, needs to be in years. 18 months is a year and a half, because again, 18 months, we know that 12 months is one full year. An extra 6 months would be half a year. So therefore, that time, we're going to use 1.5 in our equation here. So it's actually this that goes into that linear equation is going to help us to calculate what x is equal to. So let me go to the next page and I'll write that out into a linear equation for you. This is just on the previous slide here, so I can go back and forth if you need me. So next page here, we had to create this table. We called our stock fund, we simply just called that X, because the idea here is to just figure out what was invested into each account. And so what we had to figure out first was what was invested into the stock fund. The CD would come next, because the CD is just going to be what's left over. So that total amount that Kent invested was 8,000 minus X, and so that's where that would come from. But we needed more than that, because we did know too that Kent invested in that stock fund at a 6.5% interest rate over 2 years. We had to put that into we had to use our interest rate formula down here to show the second row of that table. We had to show that interest rate formula. So in the stock fund, there was the principal times rate times time. In the CD fund, there was the principal times the rate times the time. What we simply did is we added those two interest rate formulas together to show the total of interest that was gained was $855. So I'm taking everything from the bottom of that table. But what that formula will then look like then. Remember, it's more than just, the principal, which we called, the stock fund, X, plus the CD fund, which we called 8,000 minus X, is equal to our total of 8,000. We'll do that at the end. We need to incorporate the number that was calculated based on that interest. So X wasn't just X. X was actually X times 0.065 times 2. That's what we got from the stock fund. What we're going to do is we're going to add that together. So we're adding that to the CD fund. So we're adding the next formula, which was, remember, 8,000 minus X times 0.025 times 1.5 years. And that whole thing is equal to, so let me just put equal to 800. Let me give a little bit more room down here. $855, the amount of interest. So there's where we've incorporated now our interest formula. But again, since we've borrowed from two different companies, in red, there's what represents our stock fund company. And then in green, that's what represents that CD. So there's all of Kent's money right there written as an interest rate formula. And then here in blue, the $855 is the total that he's gained from that interest. So as long as we can solve for X, now we simply just have a linear equation, and we need to go ahead and solve for X. So remember, what we're doing here in red there, we're multiplying all those numbers together so we can put those numbers together. So we have 0.065 times 2 times X. So 0.065 times 2 is actually 0.13. So that's 0.13x. That is being added to what we have over there in green. Now, what's going to happen here in green, since x is written here in the parentheses, I can't combine anything with that just yet. I'm going to go ahead and multiply these two like terms first. So 0.025 times 1.5 is actually 0.0375. I want to make sure I calculated that correctly. That's what I have written down. So let me see, 0.025 times 1.5. Yeah. And so it's that number times 8,000 minus x. What we're actually going to have to do there is use our distributive property to go ahead and remove those parentheses around the 8,000 and the x. And then we'll have to combine like terms, just like we've been doing with our linear equation so far. So what I'm going to do is I'm going to go ahead and do that. We know that that's all equal to our total there, $855. But let's go ahead and combine go ahead and remove those parentheses. So I'm going to leave my 0.13x alone right now before we do any adding. So 0.0375 times 8,000 is actually 300. So I'm going to write 300 here. And then 0.0375 times negative x is going to be minus or negative 0.0375x. And all of this is equal to $855. So this is all, I know it's a little bit different with such small decimals, but it's all very, very similar to what we've been doing so far with our linear equations, in that we simply just have to remove those parentheses. Now what we're going to have to do is we're going to have to combine like terms. I can combine this 0.13x and this negative 0.0375x since they're both x's. So I'm going to go ahead and put those two together. When I put those two together, we can look at it as 0.13 minus 0.0375, and that gives us, and I'll write it here in green, 0.0925x is equal to, oh, I'm sorry, I forgot to put plus 300. I'm sorry, don't leave that out. Plus 300 is equal to 855. So just as we've done before with our linear equations, we have to completely solve for x. So let me go ahead and just add another. So we did just that on the next page again, because yes, it is to figure out what, everything that Kent invested, which we now know that x up here is 6,000. Well, 8,000 minus x, we know in the CD, 8,000 minus 6,000 is 2,000. So in the CD, he invested $2,000. And that's what gave us our total of $8,000 invested. But we could figure that out because we had to incorporate that interest rate in what was accrued over that amount of time. We did know that, and that helped us to solve that. So what we did on this page was we added together our two interest rate formulas. Here's what we got from the stock fund in red, and we added that together to what was from the CD fund there in green, and that gave us our total of $855. And we just treated this as a linear equation. You simply just are going to take those two interest rate formulas and add those together. But then just like we, with any with any linear formula, we need to go ahead and, simplify that side as much as we can. The right side of the equation we didn't have to simplify because the right side was simply just 855. But that left side of the equation we have to simplify as much as we can, and that involves combining like terms where we can, removing parentheses by applying the distributive property, and then finally solving for x. And then rewrite what we had remaining. So we have 0.0925x plus 300 is equal to 855. So what I'm going to have to do, as we've done before, I need to get rid of that 300 first since it's being added. So I'm going to subtract the 300. That's going to cancel that out. Leave me with 0.0925x is equal to 555. And then I'm going to divide both sides by 0.0925. Sorry, I know it's crazy because of a lot of numbers, but that will finally get me x is equal to 6,000. So what that means is, and what's going to be asked of you on these types of questions, I'm going to want to know how much was invested into each particular account. In this case, remember x, let me go back at the end. We found that x was equal to 6,000, and so that's what he invested into the stock fund. So we'll just call that, the first one. So number 1 is equal to 6,000. The second fund, remember that was 8,000 minus x is what we called that one for the principal. And so based on that, we know that 8,000 minus 6,000, therefore would be 2,000. So in stock fund number 2, and he invested $2,000. So that is what I'm going to ask of you on your all's quizzes on that. So, and that's what's going to be asked of you on the Alex assignment too, that it's going to ask how much was invested into each account. So you'll have two different answers. Okay. So whether it's an investment or perhaps even a borrowing situation, it's going to be treated the exact same way. So if, let's say, I'm going to, take another very, very similar one. Let's say, and this is actually from the bottom of page 95, if you're, in your e-text. We have a student who borrowed money now. He's borrowing money. It doesn't say why. Let's say it's it shows that it's a lending institution, but he's borrowing money, and it says his name is Franz, and Franz borrowed a total of $10,000. He's borrowing a total of $10,000. Part of the money was borrowed from a lending institution that charged 5.5% simple interest. So that lending institution is going to gain 5.5% of that money, whatever was invested. Again, he didn't invest the total $10,000 to that lending institution, so it's going to be based on however much was borrowed from that institution. The rest of the money he borrowed from a friend, who Franz paid 2.5% interest. So this is from the lending institution. I'll just abbreviate that as LI, and this is from the friend. 2.5% interest. Franz paid his friend back after 9 months. 9 months is 3/4 of a year. So if we look at it that way, 9 out of 12 months is 0.75 years. So that's the number we're going to use here. So that's the total amount of time it took for him to pay his friend back. And he paid the lending institution after 2 years. Okay. So we know the total amount that Franz had to pay in interest. We know that total amount of interest was $735. So if we know that, I want to know how much money he borrowed from the lending institution and how much money he borrowed from his friend. Again, he didn't split it 50-50. It wasn't like we just know that it was half and half. We know that there was a certain amount that he took from that lending institution and a certain amount he took from a friend. But based on these numbers, we should be able to figure that out. So just as we've done before, we're going to... Oh, shoot. So that table, again, will show our calculation for our principal and then our interest rate. Okay, so our principal and our interest. Remember, the first company he borrowed from was a lending institution. The second was a friend. Okay. And then the last column, we just write out that total. So remember, what happens, we'll just call that lending institution X. The idea is to just solve for X, and then the amount that, the friend borrowed was just the rest. So we know, remember, that the total was $10,000. So therefore, what he borrowed from his friend was just what was remaining. So 10,000 minus X is what we're going to call that. The principal row up there at the top will always look like that. The interest, again, we have to incorporate the interest rate formula. The I is equal to PRT is what's going to be put into each of these boxes down in this row. So for the lending institution, remember what happened for the lending institution was that, it was the principal. So remember, we're calling the principal just X at a 5.5% simple interest rate. So using the decimal for that would be 0.055. And he paid that lending institution back after 2 years. So there's our time. So there's our PRT right there in this row for the lending institution. We also have to put in our PRT for the friend. So remember that principal, we're just calling 10,000 minus X. The rate that he paid the amount of interest that he paid his friend back was a 2.5% interest. So that will use the decimal 0.025. And he paid his friend back after 9 months, which remember was 0.75 years. So that's what we're going to look at here. And that's going to give us a grand total of, we know the total amount of interest that he had to pay was $735. So we're going to use this down here in green as our linear equation to help us solve for X. let's do that. So we can write that out as x times, this is what's from the lending institution, 0.055, I'm trying to write real small, hard to do with my finger here, times 2, plus what was borrowed from the friend, which is 10,000 minus x times 0.025 to the original. Oh, there it is. It's still there. Sorry, guys. Times 0.75, which equals 735. All right, I got it all on one line with my fingers there. Okay. So what we're going to do, just like we did before, I'm going to go ahead and combine what we can. So right here before this, where this plus sign is, I'm going to go ahead and multiply those two numbers. And in doing so, I'm trying to do it at the same time. 0.055 times 2 is 0.11. So I'm going to write this all down in blue now. Or let's write it in red. 0.11x is what we've gathered by combining these three up here. Remember, that's going to be added to what we get down here. I'm going to go ahead and multiply these two before I can then apply the distributive property to combine all three of these. So 0.025 times 0.75 is, very small number, 0.01875. And I'm just using everything in this decimal to be as specific as possible. And then that's what's going to be multiplied by the 10,000 minus x. Okay, and all that is equal to 735. Oh, 735. Okay, so let's apply that distributive property there so we can go ahead and remove those parentheses. So 0.01875 times 10,000 is, let's see, and let me write what I'm left with here, so I'll put that here in blue. Obviously, I haven't done anything. I'm just applying the distributive property right now, so 0.11x is going to remain there. 0.01875 times 10,000 was 187.5. And then 0.01875 times negative x is going to be written as minus 0.01875x. And all of this is equal to 735 still. Okay, now we can combine our like terms. I can go ahead and combine 0.11x and then the minus 0.01875x, since those are considered like terms. So 0.11 minus 0.01875 is, write this here in black, 0.09125x plus 187.5 is equal to 735. Okay, now it's just a matter of solving for x. We need to get x by itself, so I'm going to subtract 187.5 from both sides, leaving me with 0.09125x over there on the left is equal to 735 minus 187.5 equal to 547.50. And then we're going to divide both sides by that 0.09125. Divide both sides by that. Okay. And dividing by 0.09125 gives us 6,000. All right, coincidentally, we end up with 6,000. So I'll write that out. That means if x is equal to 6,000, that shows you how much was borrowed from the lending institution. Since the friend was just what was left over, remember, then we just need to take that total $10,000 minus x, which we know is 6,000, and 10,000 minus 6,000 we know is 4,000. So therefore, Franz borrowed 6,000 from the lending institution and 4,000 from his friend. So those are our two answers there, and I will double check that. I think they give us the answer somewhere. Maybe not. Oh, it does. On the bottom of 95, it does tell us the answer. Franz borrowed 4,000 from his friend and 6,000 from the lending institution. So we did get that correct. So that's how we take a look. That's how we will every single time calculate. I can't talk today either. That simple interest. Okay. So moving forward, what we're going to see then in the next section, so this is the last section we'll take a look at in this lecture. So in the section 2 that says solving applications involving mixtures, these can actually be set up the exact same way. We'll use a table when we're creating mixtures to show how much mixture is needed. Let me give an example. So there's an example in your book on page 96 that talks about, what happens if we mixed two different mixtures. Now this is very, very similar as it talks about in the very beginning. What we were doing in the first section, we were mixing two different investments that had two different percentages as far as their interest rate. This is actually going to be quite similar, except we're mixing solutions that have different concentrations. If we took, for instance, just to give a visual example, if we had, say, sugar water, where if I had mixed half sugar and half water, that's a 50% concentration. If I mix that with something that was only 2% sugar, that means that there's more water in it than there is sugar. If I mix those two together, a 50% solution and a 2% solution, depending on how much I used of each solution, I have now created somewhere in between. I may have a 27% sugar water solution based on how I've mixed that. And that's what we're looking at in this section, that we're looking at how we can mix two different types of mixtures to create a different percentage of a mixture. So let me give you an example. So the one that's on page 96 says, household bleach contains 6% sodium hypochlorite. So just to write down the examples here, or to write down the numbers. So that particular solution has 6% sodium hypochlorite. How much household bleach would be combined with 7 liters of a weaker, 70. So we have 70 liters of a weaker 1% solution. So remember, this is the bleach. Bleach contains 6%. We already know we have 70 liters of this weaker 1% solution. I want to know how much bleach would we be able to combine? So how much of that top product, the bleach product, would we be able to combine with this lesser hypochlorite solution to form something that is 2.5%. So very similar, we're looking to see how much fluid, so I guess how many liters, would create a 2.5% solution. So like in the example that I gave you, if I had sugar water, that was like a 50% sugar water solution, and I was mixing it with only 2% sugar water, something that doesn't have that much sugar in it, I would need to know a specific amount that I would need of each volume to be able to create, say, that 27% instead. I don't want a 50% solution. I don't want a 2% solution. There should be a certain amount of volume of each one that I can combine if I needed a 27% solution. In this case, same idea. I don't want a 6% solution, and I don't want a 1% solution. Maybe the bleach is too much, and then the 70 liters that we have of the other solution is not enough. We want this concentration. So how do I do that? Well, what we can do is do the exact same thing that we did before, and let's create a table. So in that table, what we can do is we can create the top row. We'll just say that this is the amount. I'm just going to put amount of solution. I'm just abbreviating. That says SLN. Sorry, horrible handwriting there. Meaning the amount of liters that we'll need of our solution. The bottom row, how many, what contains that pure sodium hypochlorite. So let's just write, and I would abbreviate it, but let's just put sodium hypochlorite, which is what we're talking about in this particular question. So remember, the bleach was a 6% solution, a 6% mixture there, whereas then the other substance that we were using was a 1% solution. So the idea is to be able to add these two together to create that 2.5% solution. That's what we're doing. That's the idea. But remember, we already know that we have 70 liters of that 1% solution. So what we're trying to figure out is how much bleach we need. So we'll just call bleach X, just like we did before. So then therefore, what's going to happen is that 2.5% solution is going to be our x plus 70. That's what we're trying to figure out, is what amount of bleach can be added to that 70 liters. We already have that amount of volume. But remember, we have to incorporate these percentages. So you remember that the bleach was 6% sodium hypochlorite. So what we'll do is we'll call that 0.06, just like we did in the first section, since that's representing 6%, X. Since the bleach we're calling X. Whereas then the 1% solution, we already know that that's 70, so therefore this would be 0.01 times 70. We already know what that number is since we didn't call it X. We're not needing to solve for anything there. And then lastly, we want to create that 2.5% solution, or in other words, 0.025 times, remember we're calling this one X plus 70. So it's very, very similar, except we're not having to really think about the interest rate formula being PRT. This is simply just whatever that number is that we're representing on that top row times the percentage. So in, the bleach, it was a 0.06, in the lesser solution 0.01, and what we're trying to create is a 0.025 times, again, what's in the top row. So here, just like before, is where we will get that linear equation. So I'm going to actually just jot that down on here. So that we will call 0.06x, as we saw that in the first. Then adding that to 0.01 times 70, and we can just easily multiply those together, is equal to, so there's our equal sign, sorry, horrible handwriting there, 0.025 times x plus 70, as we called that. That's just the whole bottom row of that table that we had created. So here we have our linear equation. What I can do is I'm going to go ahead and combine that right there. Go ahead and multiply these two together to show that would now be 0.06x plus 0.01 times 70 is going to be 0.7 is equal to, and let's go ahead and apply the distributive property here. 0.05 times x is going to be 0.025 times x is 0.025x, and 0.025 times 70, so since it's positive 70, that's going to be just plus 1.75. Okay, so now anywhere we can combine like terms? No, on the left side of the equation, we have a variable and a number. On the right side, a variable and a number. So I can't combine anything on the same side. But just as we've done before, I can move. I want to make sure I'm solving for x, so I want to make sure x is only on one side of the equation. So I'm going to go ahead and subtract it from this side, since that's the smaller one, and I'll make sure I do the same thing over here, 0.025x. And so over here on the right, that's going to cancel that out and leave me with my just 1.75. But over here, 0.06 minus 0.025 x is going to be 0.035x plus 0.7, as that's just going to remain there. And then on the right side, we just have the 1.75. So just as we normally do in solving for x, I want to get rid of whatever's being added or subtracted from the x. I'm going to subtract, because it's the opposite, the 0.7. Canceling that out over on the left, leaving me with 0.035x is equal to 1.05. And then dividing both sides by that 0.035 to get x by itself completely. But doing that to both sides, just as we've done many times before, that leaves me with x is equal to 30, which means we will need 30 liters of bleach to combine with the 70 liters of that lesser solution. And that small amount of bleach, the higher concentration, we'll obviously want to use less of that one, since it's such a high concentration, and more of the lower concentration to create something so low like 2.5% solution. So that makes complete sense there. So hopefully that makes sense, as that's going to be set up the exact same way. I'll go ahead and do another one for you guys so you guys can see exactly what I'm talking about. Let's see, I'm grabbing one. Okay, here's one. I'll grab the skill practice one out of your book there. So I'm 96 for those of you guys looking at your text. Again, if you're not looking at your text, no big deal. I will write this problem down for you. So this one is asking me, just like the first one, we have a 4% acid solution. That's all it says is a 4% acid solution. What I do have, I want to know how much of this is going to be needed and combined with, I have a total amount, 200. I have 200 milliliters. And we're going to end up having to put this in liters, I believe. So we have it, not I believe, but that's something to think about. We've got 200 milliliters of a 12% solution. What we're trying to do is create a 9% solution. So 9% solution. So, again, the question very similar to our bleach question. I want to know how much of that 4% solution is going to be needed to add to 200 milliliters of that higher concentration solution, that 12%, to create something that's in between, a 9% solution. So, just as I've done before, I'm going to go ahead back to it. The original question was asking us how many milliliters of that 4% solution would we need. We just discovered that we would need 120 milliliters of that solution. And that would be added to 200 milliliters of 12%. Because of the combination of those two percentages, that would create then a total of a 9% solution. And we figure create a table. So, just like we did on the last one with the bleach. So we've got two columns. The first column is the total amount of that solution. So how much will be needed. I think actually, because the last one was in liters, this one, the fact that it's in milliliters doesn't matter. It's just that your answer will also be in milliliters. So if there's a question that asks how many liters, we would have to convert it, and we haven't talked about that yet. So you don't need to worry about that. If the solution comes in milliliters, I will ask how many milliliters are needed. So I wouldn't change that up on you for any reason. So just the amount of solution. And then remember, the bottom row incorporates that acid percentage, so the percentage of that substance. So the first substance that we were looking at, remember, was a 4% solution, whereas the second substance was a 12% solution. So remember, the idea is we're adding these two together to create a 9% solution. So that is, in summary, what is happening up here at the top. That we're adding the 4% solution to the 12% solution to get a 9% solution. But there needs to be a specific amount of each. The first one, not the first one, but the 12% solution, we already know how much fluid we have of that. We already know that that's 200 milliliters. So therefore, what we're going to do is we're going to call the 4% solution, we're going to call that X, and then we're going to call that 9% solution, we're just going to simply call that X plus 200. Because it's the combination. What we're doing in these boxes here is we're adding the first one to the second one to get that third box. So that's what we're going to do here. But again, to get that linear equation from this, we have to just incorporate those percentages. So for that first one, since that's a 4% solution, we're going to write that one out as 0.04. That's how 4% would be represented as a percent times X, because we're just multiplying it by what we're terming the 4% solution. We're just calling that X, so that's what we're trying to solve for. Whereas then we're going to end up adding that to the second box then, which again we've called which is 200 milliliters, but since it's a 12% solution, that is going to be 0.12 times 200 milliliters. So a little bit more so than just what we have there. And that will be equal to what we have in the last box, which is a 9% solution. So that one would be written as a 0.09 times X plus 200. There we go. So there's our linear equation down there at the bottom, written in green. We've got 0.04x plus 0.12 times 200 is equal to 0.09 times x plus 200. So let's go ahead. I'm going to go ahead and original question by creating this table. So very, very similar to what we did with our interest rate formula. So you guys will expect to see on the midterm a couple of those questions. So I will only put I know that we could go a little bit further and get into uniform motion in the next section, but I'm going to go ahead and stop there, and that will be the end of our algebra class there. So we'll just finish up with just the interest rate formula and then the applications involving mixtures. If you guys have any questions at all, let me know. Screen here and just rewrite what we have as that formula, or as that linear equation there. So 0.04x plus, I'll go ahead and, well, actually I'll write the whole thing out. 0.12 times 200 is equal to 0.09 times x plus 200. That's what we have here. Okay, so let's go ahead and simplify each side of the equation as best as we can. So I can start by over here on the left. I can go ahead and multiply those two numbers together to leave me on the left with 0.04x plus 0.12 times 200 is 24 is equal to, and then on the right side of the equation we do need to use that distributive property. 0.09 times x is going to be 0.09x, and then 0.09 times 200 is 18. So what that means is we've got both sides of our equal sign completely simplified. I have a variable and a number on the left, and a variable and a number on the right. So what I can do now is I want to move my variable from one side of the equation to the other, as we've done before. You guys know I'm typically in a habit of taking the one from the right and moving it over to the left. But you'll notice what would happen is if I took 0.09 and I subtracted that from 0.04, I'm going to end up with a negative number. So there's nothing wrong with taking the one from the left and moving it over to the right instead. So what I'm going to choose to do, and it doesn't matter which one you choose there, if you did end up with a negative number, you still, as long as you subtracted it correctly and do all the steps the same way, you'll still end up at the end with the same answer. So that is totally fine if you did choose to subtract 0.09 from this side and from this side, that would be fine. But I'm going to go ahead and select to subtract 0.04 from that left side to cancel it out from the left and leave me with just 24 over there on the left. Whereas then doing the same thing over on the right side, that's going to then leave me with a positive number instead of a negative number. So I'm left with 0.05x plus 18. Okay. So then we know that in order to get x completely by itself, so there is our x, it's horribly drawn there, but there's our x over there now on the right. So we need to get it by itself. So as usual, I need to remove whatever's being added or subtracted first. So I'm going to subtract 18, and that will cancel that out over there. And make sure we do the same thing to the other side. So 24 minus 18 is 6, and then that's going to also have that be equal to 0.05x that's left still over there on the right side. And then to get x completely by itself, since it's being multiplied by 0.05, I'm going to divide by 0.05 to cancel that out and leave me with x over on that right side of the equation. But we have to do the same thing to the left side of the equation, and 6 divided by 0.05 is 120. So therefore, we would need 120 milliliters of that 12%, the 4% solution to be combined with that 200 milliliter.